Cannabis extract enters the body as a concentrated mix of cannabinoids, terpenes, and carrier oils. The active compound responsible for most physiological effects is delta-9 THC. Once THC reaches the bloodstream, it binds to CB1 receptors in the central nervous system and CB2 receptors throughout the immune system. This binding changes neurotransmitter release patterns, shifts perception, adjusts pain signaling, and modulates mood and appetite regulation. When THC is taken sublingually, it bypasses first-pass liver metabolism. The extract is held under the tongue. The membrane there is thin and highly vascular. Lipid-soluble cannabinoids absorb directly into the capillaries. This produces higher bioavailability than swallowing an edible. On average, sublingual dosing results in faster onset, more consistent effects, and fewer metabolic byproducts. The liver eventually processes what isn't absorbed sublingually, but the initial wave is cleaner and more efficient. Carrier oils change absorption speed. MCT oil moves cannabinoids across cell membranes more efficiently than olive oil or hemp seed oil. Sunflower lecithin improves emulsification and increases the number of cannabinoids that reach circulation intact. These factors shape potency. Two extracts with identical THC content can produce different effects depending on the carrier. Nano-THC shifts the equation further. Standard THC molecules cluster into larger droplets that the body struggles to absorb. Nano-emulsification breaks THC into extremely small particles suspended in water-compatible carriers. The reduced particle size increases surface area and diffusion speed. These particles penetrate mucosal tissues rapidly and remain stable in digestion. The result is faster onset, higher absorption percentage, and more predictable dosing. Nano-THC behaves more like a water-soluble molecule, moving through biological barriers that normally resist cannabinoids. Once THC reaches the bloodstream, distribution begins. It crosses the blood-brain barrier easily due to its lipid solubility. CB1 receptors in the cortex, hippocampus, basal ganglia, and cerebellum respond immediately. These regions regulate memory formation, sensory perception, emotional tone, movement, and time perception. The high is the combined subjective output of these receptor interactions. CB2 binding influences inflammatory pathways, immune signals, and localized tissue responses. Metabolism follows a two-phase process. The liver converts THC into 11-hydroxy-THC, which is often more potent and longer lasting. This metabolite then converts into THC-COOH, an inactive form that the body eliminates slowly through urine and feces. Sublingual and nano delivery alter the ratio of direct THC absorption to metabolic conversion. This is why sublingual and nano products feel cleaner, faster, and more controllable than edibles. The final variable is tolerance adaptation. Repeated THC exposure downregulates CB1 receptor density. This reduces subjective intensity over time and requires higher doses for the same effect. Breaks restore receptor numbers and metabolic sensitivity. This is the complete pathway: administration, absorption, distribution, receptor binding, metabolic conversion, and elimination.